Good morning, everybody. Welcome to robotics class. So this is week 25, and we are actually starting unit 5 this week. So we're going to be learning about the distance sensor. So we're learning about a new sensor, and we'll still be inside of the wall maze challenge. So the same one that we used the last time, except we're learning how instead, remember we were using our bumper sensor. This time we're using a distance sensor. So remember, robots have a lot of different sensors, and the sensors help to give the robot intelligence, right? And give them the ability to know, to gather information about their environment so that they can then make decisions. So they pretty much like they give, like how we have our 5 senses, right? We have to give the robot the ability to collect information about their environment, right? What are they seeing? How far are they from an object? What do they do if they hit a wall? As we found out, and so we have to be able to understand that there are a lot of different sensors, and the sensors all help to have the robot do what we're trying to get the robot to do. So in this case, we're going to be doing the wall maze, except we're going to be using the distance sensor. So I'll actually put this short video on for you guys just to talk about it. So hang on.
In this unit, you will learn how to use the distance sensor on the VR robot. The VR robot has one distance sensor that is combined with the front eye. The distance sensor is used to report the distance between the VR robot and the nearest object. Unlike the bumper sensor, the distance sensor allows the VR robot to detect walls or other obstacles without touching them. Using information you learn about the distance sensor, you will get the chance to apply your new skills to solve the wall maze challenge without bumping any walls. In this challenge, the VR robot will use the distance sensor to navigate through the wall maze playground. Have fun learning how to solve the wall maze challenge.
She's very excited about it. Hopefully you guys are excited. We're going to navigate the wall maze challenge, but we're going to use a distance sensor. But we have to learn what in the world is a distance sensor and how does it work. So that's basically what we'll be going through in lesson 1. We're going to learn about the distance sensor and how it reports the distance between it and the nearest object, right? We'll identify that the distance sensor determines distance by using the time it takes for ultrasonic waves to bounce off an object and return to the sensor. So we'll get a little bit more in detail about that. We're going to identify that the distance found object block, that's the new block we're going to be using, is a Boolean reporter block that reports if the distance sensor has found an object. Identify that the distance from block reports the distance of the nearest object in millimeters or inches, and then we will be using it in the project. So here is our robot. So the distance sensor is located right here at the front of the robot. Okay, so there it is. And it's basically like the front eye of the robot, right? So you see the robot, remember there was the 2 touch sensors, the bumper sensors, and then there's the distance sensor right there. So if we were to have a real robot, we could take a look at it. And you actually can get this model robot if any of you guys are ever interested in like doing this at home with a real robot. They do actually sell these robots. So it is possible to do that if that's something that you're interested in, and you like want to pursue that at home, that'd be a great thing to do on your own. So pretty much here it is. You see what it looks like. And so what it does is it calculates distance by using the time it takes for ultrasonic waves to bounce off an object and return to the sensor. So there's our little robot sending out ultrasonic waves and trying to calculate the distance between it and the object in front of it. So I did, and I'm always like a little bit, like, I don't know how much detail to go into because again, it's like, number one, we're not all together. And so I can't really even gauge like where you're at, but I feel like I should just lean on keeping it really basic because I feel like most of you guys aren't even doing the work anyway. So why should we go more into depth with the topics? Probably not a good idea. Um, so we'll just keep it basic. But if you're somebody, if you're one of the kids, and I shouldn't even say that because you know what, I don't want to make anybody feel bad, but there's kids who do their work every week, and I'm so proud of you. You do the code, you send it in, and you really try. So that's amazing. And I'm really proud of you. And then there's other kids who like, I don't know what you do, but you don't do any of it. But if you're one of the kids who's really interested in this, they will, if you click around in here, they have a lot of articles and different like teaching things, and they'll teach you all about the distance sensor. So if you want to go more in depth about it and you're like, oh, I really want to learn about this, I won't go through this with you guys, but they have a lot of information in here that will explain it in more detail to you. So basically, we're just using the distance found object block. So the distance sensor detects if there is an object in front of it, right? So it uses the distance found object block in the project. And the distance found object block is a Boolean. So remember, a Boolean value is true or false, right? And it's one of those hexagonal blocks. So this is what it looks like, distance found an object. And that's what the block looks like. Let me see if I could I'm just opening up VEX code just so I have it. Let me go to a new project. Okay, so I'm just getting all the blocks out. So remember, it is a Boolean block. Here it is, distance found in object. Okay, so it's under distance sensing. The distance found object reports true when the distance sensor detects an object or surface within its field of view and within 3,000 millimeters of the sensor. Okay, so that's when it will detect true. The distance found object reports false when the distance sensor does not detect an object or surface within 3,000 millimeters. So that's basically like the default of what it's doing. So remember, sensors, they need like some information to be able to know if it's true or false, right? And so in this case, they're giving them that 3,000 millimeter mark where they're saying if it's within that, it's true. If it doesn't detect that and it's without of that range, then it's false. The distance from block. The distance from block is a numeric. So this has a number and it reports the distance of the nearest object from the front of the VR robot. So it will actually come back with a number. And so the block for that one is right here, distance in millimeters. So you can choose whether or not you get the distance in millimeters or in inches. Okay, so there's like a little pull down menu. And it can be used with other blocks in a project to instruct the VR robot to drive a certain distance away or toward an object, right? Or to complete an action when a specific distance is reported. So in the following example, you can see how the distance block is used inside of a Boolean reporter block. And then in this project, so we will actually give this a try. The VR robot will drive forward until the distance reported is less than 50 millimeters, and then it'll stop. So here we go, look. When started, drive forward, wait until the distance in millimeters is less than 50, and then stop driving. So that's pretty much what we're doing. So the distance sensor can detect if there's an object in front of the VR robot, and this could be used to avoid or find a wall or an object. So we know in our maze, we're using it, right, to measure the distance between the front of the distance sensor and the front of the wall. And so then that way we can find out, you know, when we need to turn, right, and what we need to do. So using the distance sensor will allow the VR robot to drive up to an object without touching it. And this can be helpful in the maze, right? Because we don't want to have to keep bumping into the walls, right? So it can continuously drive through without bumping into the walls. So let's watch this video of the robot actually going through the maze using the distance sensor. So let's see what that will look like. So there it goes. And you notice it's a little bit different than how it was with the bumper sensor. It's not actually bumping into the wall. It looks more kind of more like a smooth turn, right? And then it's turning. So it's interesting to see how the different sensors work, right? And so hopefully you're starting to get a little bit more comfortable. And guys, remember, this is really like, this is new for like everybody, right? Because these aren't things that you're just like, oh yeah, distance sensor, right? So it's okay. Like, I'm not looking for perfection. It's like I'm just looking for effort. So when you're doing your work every week, and pretty much I give you all the answers to the code anyways in the videos, but I'm not looking for like everything perfect. And you could give me a dissertation on, you know, the distance sensor. I'm just looking like, okay, did they try it? You know, like what happened? Are they, you know, putting an effort to like learn the concept, right? And so that's basically what I'm looking for, right? And if you've noticed, you get 100 if you give it a try with the code. So like for the kids who just, they tried the code out, maybe it's not even perfect, but at least they made an attempt. You get 100, right? And so it's always better to at least put the effort in and try than to be like, oh, distance sensor, what is this? I don't know what that is, and then just give up before you even try. Remember, robotics is all about growth mindset, right? It's all about being willing to fail. And I know that is probably a fear of every one of you. You don't want to ever fail at anything. But the thing is, that's not, it's just not real life, right? Failure is part of life. And failure can actually be a good thing because it means that you're learning something and that the next time you go and you try it, you're going to get it right because you failed and you learned how to do it the right way. And so that's definitely something that you want to get comfortable with, especially in the field of robotics and coding. You have to be comfortable with failure. Here I am sitting here telling you to be comfortable with failure. Failure, if you are doing nothing, that's your own fault. That's not the kind of failure I'm talking about. Laziness and like, well, I'll just fail again. That's not what I'm talking about. I'm talking about you put an effort in, you were really trying, but it just didn't work. The code didn't work, it failed. And then you just said, well, you know what, let me go back and see where the mistakes were, and you fix them and you get it to work. That's what I'm talking about. That you're okay, that it won't be perfect the first time. Okay, so let's see, we're gonna go in now. We're gonna start a little project. So we're going to look for the blocks. We have our when started. Excuse me, we want our drive forward. So let's go to our drive blocks, our drive forward. And then we're going to get our wait until block. So if you remember where that is in the control flow, get our wait until block. And then we're going to get our, so our green blocks, if you look, there are operator blocks. So that's where it allows you to put in like numbers and things like that. So if we grab one of those, we plug it in, then we can go get our distance in millimeter block. So that would be, let's find our distance in millimeter block. There it is in the distance sensing. Plug her on in. And then we want our stop driving block. Let's go back up to our drivetrain. Let's get our stop driving and connect it. And now let's give it a go in the wall maze. Let's see what happens. Oh, I hope it didn't get frozen. Okay, so I know it's hard to see because the robot's always at the bottom, but it pretty much, it went up and then it stopped. So it worked. So you remember the last time when we were using the bumper sensor, it was the same thing. We had the robot drive until the sensor showed us true and then it stopped because it hit the wall. And so it's the same thing here. So you're going to get to test out this code in your assignment this week. So you could rename this. You could rename it unit number 5, lesson number 1. My gosh, what is wrong with me today? I don't know. Distance sensor. Name it distance sensor. Okay, and then rename it. Okay, so that's what you're gonna rename it, and then you can send me that code. So it's so easy, you know. Usually the lesson ones in the units are just very like basic. You're just getting comfortable with the code, and then as the weeks go on, so let me see. I'll tell you guys what's going on with this one. So this is unit 5. So unit 5 we're gonna do lesson 2. We're gonna be using the comparison blocks. Then we're going to be driving to the letter A. Then there's a mini challenge. We'll be learning about sensor values, and then reaching the letter B, there's a mini challenge, and then there's the wall maze challenge. So there are a bunch of lessons within this, and they all build upon each other. So that's why they're part of the unit. So we're basically every lesson using the distance sensor until we get through the entire maze. So that is our goal for this week. So that'll be your code. And let me go through, hang on 1 minute. Okay, so I just wanted to pull up the quiz. So there is a lesson quiz. So it's VR, Mexico VR, Unit 5 Lesson 1 quiz. So true or false? The distance sensor reports the total distance the VR robot travels. So that's false, because why? It doesn't. It's the distance to the nearest object, right? True or false? The distance sensor determines distance by using the time it takes for ultrasonic waves to bounce off an object and return to the sensor. So yes, we know that's true, right? Which block reports if the distance sensor has found an object? So which of the blocks are we using? Is it the pressing bumper? No, because we're not using the bumper sensor. The distance from block, the distance found object block, or the color near. So it's the distance found object block. Then we're talking about the distance from block. So the distance from block reports the distance of the nearest object in meters and inches. So it's millimeters, right? And inches. Which of the following is an advantage to using the distance sensor in a VexCode VR? To complete a maze without continuously bumping into the walls. That's pretty much the answer, right? It's trying to actually smoothly go through the maze without bumping into the wall every time. So those are your questions for your quiz. So take your quiz and do your code, and then that's your lesson for this week, okay? All right, guys, we'll see you next time. Alrighty, bye, guys.